The pancreas is a pale gray gland, about 12 to 15 centimeters long and weighing about 60 grams. It is situated in the epigastric and left hypochondriac regions of the abdominal cavity. Structurally, it has a broad head, a body, and a narrow tail. The pancreas is a heterocrine, or mixed, gland, meaning it functions as both an exocrine and endocrine gland. The exocrine part is composed of acini, which secrete digestive juices into the duodenum. The endocrine part consists of the islets of Langerhans, which secrete insulin and glucagon directly into the blood. The islets of Langerhans contain three major cell types. Alpha cells make up about 25% of the total cells and secrete glucagon. Beta cells, about 60% of the cells and located mainly in the middle, secrete insulin and amylin. Delta cells, about 10% of the total, secrete somatostatin. Insulin was first isolated from the pancreas in 1922 by Banting and Best. It is a polypeptide of about 50 amino acids, composed of two chains connected by disulfide linkages. Its main function is to lower raised blood nutrient levels, promoting the storage of glucose, amino acids, and fatty acids through anabolic effects. Insulin promotes nutrient storage by stimulating uptake and use of glucose by muscle and connective tissue, increasing glycogenesis in the liver and skeletal muscles, and accelerating amino acid uptake for protein synthesis. It also promotes fatty acid synthesis and storage, while decreasing glycogenolysis and preventing the breakdown of protein and fat, and gluconeogenesis. Insulin secretion is stimulated by increased blood glucose levels, particularly after meals, parasympathetic stimulation, and raised blood amino acid and fatty acid levels. Gastrointestinal hormones like gastrin, secretin, and cholecystokinin also stimulate secretion. Secretion is decreased by sympathetic stimulation, glucagon, adrenaline, cortisol, and somatostatin. Glucagon is a large polypeptide secreted by the alpha cells of the islets of Langerhans, composed of a chain of 29 amino acids. Its most important function is to increase blood glucose concentration, an effect opposite to that of insulin. It is a hyperglycemic hormone. Only 1 microgram per kilogram of glucagon can significantly elevate blood glucose within about 20 minutes. The major effects of glucagon on glucose metabolism are the breakdown of liver glycogen, or glycogenolysis, and increased gluconeogenesis in the liver. Both enhance glucose availability to other organs. In high concentrations, glucagon also enhances heart strength, increases blood flow, particularly to the kidneys, enhances bile secretion, and inhibits gastric acid secretion. The regulation of glucagon secretion is straightforward. Increased blood glucose inhibits glucagon secretion. Conversely, increased blood amino acids stimulate the secretion of glucagon. Physical activity, specifically exercise, also stimulates the secretion of glucagon. Somatostatin, also known as GHRIH, is also produced by the hypothalamus. The primary effect of somatostatin is inhibitory. It inhibits the secretion of both insulin and glucagon, as well as the secretion of growth hormone, or GH, from the anterior pituitary. Diabetes mellitus is a syndrome of impaired carbohydrate, fat, and protein metabolism. It is caused by a lack of insulin secretion or decreased sensitivity of tissues to insulin. The two main types are type 1 or insulin-dependent and type 2 or non-insulin-dependent diabetes mellitus. In both types of diabetes mellitus, the metabolism of all main foodstuffs is altered. The basic effect of insulin deficiency or resistance is to prevent efficient glucose uptake and utilization by most body cells, except the brain. As a result, blood glucose concentration increases, cell utilization of glucose falls, and the utilization of fats and proteins increases. Type 1 diabetes, or insulin-dependent diabetes mellitus, is caused by a lack of insulin secretion. Causes include injury to the pancreatic beta cells, diseases impairing insulin production, viral infections, and autoimmune disorders. Heredity also plays a role, causing increased susceptibility to beta cell destruction and degeneration, even without viral infections or autoimmune disorders. Type 1 diabetes, historically known as juvenile diabetes, often presents abruptly around 14 years of age, but can occur at any age. It leads to three principal consequences: increased blood glucose levels, increased utilization of fats for energy, and depletion of the body's proteins. Approximately 5% to 10% of people with diabetes have type 1. Type 2 diabetes, or non-insulin-dependent diabetes mellitus, is far more common, accounting for 90% to 95% of cases. It is initially caused by decreased sensitivity of target tissues to insulin, known as insulin resistance. Onset is usually gradual, occurring after age 30, and is often referred to as adult-onset diabetes. Obesity is the most important risk factor. Thank you for watching this video on the pancreas.